alright. Orang macam tuan-tuan, encik, puan ke cik kan, Cik Siti yang bekerja kemudian ambil masa untuk attend class. Even we have also commitment daily dan malam attend class. So I hope that this class kita taklah bosan dan you can communicate with whatever, because this topic lebih kepada geotechnical failure kan, failure mechanism. Kita ambil case history and then we're going to discuss. So the approach may be not similar to what we have during the undergraduate. So saya tak paksa untuk anda on camera ke, you nak off camera pun tak ada masalah, because saya pun akan off camera for certain time lah. And saya agak risau jugalah sebab hujan kan tadi kan, daripada previous experience, kalau hujan selalu ni internet line problem. So saya just standby lah if you say that okay kita ada problem internet connection, so I have to back up dengan another plan lah. But however, it's very lucky to have you again online. So can you start to introduce yourself, for example nama, kemudian bekerja kat mana, asal kat mana. So 3 benda tu je. So at least minggu depan kita jumpa, oh saya dah kenal, oh mana yang orang panggil Pak Tam. Saya rasa Pak Tam ni Encik Muhammad Tamizi, right? Okay, Afif saya tak tahulah nickname dia apa. Muhammad Zamir ni apa nickname kan? And then saya jarang interrupt lah because the communications among you all dulu kan. Okay, can you start with Muhammad Zamir? Introduce yourself, asal mana, kerja kat mana. 3 benda tu je. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh, Doktor. Saya Muhammad Zamir bin Muhammad Zuraini, bekerja di Plus Lebuh Raya di bahagian ni lah, bertam daripada Noda Region lah nak kata. Start daripada Jitra sampai ke Jelapang. And then saya asal Alor Start.
Oh, coverage besar lah ni.
Coverage besar sebab kami under region.
Okay, alright. Good. Nice to meet you, Encik Muhammad Zamir. And the next one, Cik ke Puan ke Siti Nurfaiza? Puan. You mute. Okay.
Assalamualaikum. Boleh dengar ke Dr. Sebab hari tu mic saya problem.
Boleh.
Maaf lewat masuk Doktor.
Tak apa saya faham sebab masing-masing bekerja kan.
Okay. Assalamualaikum. Saya Siti Nurfaiza binti Kamaluddin. Saya berasal daripada Melaka dan kini menetap di Teluk Intan, Perak. Dan kini saya bekerja di JKR Tanjung.
Okay. Division mana JKR? I mean specialist apa dia?
Saya di bahagian bangunan.
Okay. Good lah. Nice to meet you again. Okay, next is Encik Muhammad Tamizi.
Assalamualaikum, selamat malam Doktor. Saya Muhammad Tarmizi. Orang panggil Pak Tam lah. Saya sekarang ni di THB Maintenance Sdn Bhd. Konsesi dalam Seketuan di Pulau Pinang, Kedah dan Perlis.
Yes, samalah macam northern sections lah kan Encik Muhammad Zamir, right?
Cuma bezanya saya dengan Zamir jaga highway, saya jaga federal road. Itu je bezanya.
Okay, so daripada two different experience, mana best? Federal road ke apa ni? Rural road yang
dua-dua ada karakter yang berbeza, dua-dua best. Masing-masing lah karakter yang macam baru lepas habis pening musim perayaan kan.
Tapi kan northern area kita jarang dengar kan jalan raya runtuh sebab hujan lebat ke, betul tak? Banjir tu pun yang dulu kan last year yang dekat Kedah Baling kan.
Kita di northern ni kita belajar pada experience, bukan kita kata tak pernah banjir. Kita pernah banjir tapi kita government banyak belajar pada experience. Bila banjir kita raise up level macam tu lah. So lepas kita buat preventive punya treatment apa semua, benda-benda tu berlaku tapi dia tak kurang lah efek pada jalan-jalan. Saya sebut jalan federal lah. Saya rasa highway pun sama sebab kita berada di kawasan yang landai. Dia tak sama dengan Perak, dia tak sama dengan sebelah Johor, sebelah selatan saja mungkin kawasan hilly area apa semua tu beza-beza kat sini lah. Kita beruntung lah berada di kawasan yang landai macam di Kedah.
Betul sebab Sebab bila kita cerita pasal highway, landai semua ni and our cost lebih pada geomechanic failures kan. So ada antaranya slope stability failure. So yang tu pun kita akan cover in future lah. Among it's related to landslide lah. Itu tak silap saya chapter 5 yang terakhir. Okay.
Kita ada doktor, landslide kita ada. Macam di Kedah ni kita banyak bertumpu di Gunung Jerai sebab kita ada laluan federal kat situ, ada 10
Okay,
km.
okay.
Kita pernah face problem landslide satu hari lah. Berapa lokasi yang runtuh tapi sekarang dia dah settle lah semua tu.
Okay. Okay, nice. And thank you Encik Muhammad Tamizin dan Muhammad Afif.
Okay, Assalamualaikum dan selamat malam doktor. Nama saya Muhammad Afif bin Asaudi. Saya berasal daripada Kelantan dan bekerja di JKR HQ, bahagian perkhidmatan forensik struktur.
Oh, forensik struktur lah. Dengar forensik ni teringat cerita CSI lah. So, your experience lah from your own hands-on kan, from the beginning you dapat problem kan, and then what was the apa kata biggest challenges ke yang you pernah face, and then how many cases you have when
Macam mana doktor tak dengar?
maksud saya daripada pengalaman yang lama kan, macam mana awak berhadapan untuk investigate, sebab kita nak menyiasat benda yang dah mengalami failure kan. Lepas tu kita nak datangkan dengan solution, mitigations. Mana yang susah? Susah untuk dapat kes yang baru sebelum failure ataupun kes yang selepas failure? Maksudnya kes sebelum failure tu new development kan, new project. Of course lah tak ada apa-apa sangat kes kan. So antara pengalaman Cik Muhammad Afif sendiri mana?
Kalau bercerita pasal pengalaman ni, saya boleh dikatakan baru jugalah
Okay.
dalam bidang ni. Saya graduate tahun lepas 2022.
Okay.
Kalau cerita pasal apa ni, kes bagi saya lah, kalau failure yang selepas construction ni macam lebih susah sikit lah untuk, lebih mencabar sikit lah untuk apa ni, kerja-kerja pembaikan, pengesyuran apa semua. Apalagi macam benda tu yang melibatkan isu apa ni, macam contoh yang baru-baru ni dekat tanah runtuh yang dekat apa ni, Jalan Duta tu. Dia
Okay.
melibatkan isu yang ada liputan berita apa semua tu, yang tu lebih kata lebih mencabar lah sikit sebab kena
Mencabar,
solve
kan?
benda tu dalam masa yang cepat segera.
Yelah kan, main dengan federal government, semua nak cepatkan, and then public, yelah kepentingan orang awam kan. Okay.
Betul.
Thank you again for sharing all your experience. Again, mungkin tu saya kagum dengan anda punya pengalaman. So tak perlu segan, saya mungkin rasa saya lagi tak tahu apa berbanding encik-encik Puan Siti kan, sebab saya rasa daripada pengalaman saya ada jugalah, tapi nak real face condition tu I might not have as what yours lah. Okay, not to orang kata apa, lewat lah our class sessions. So selalunya saya nak tanya lah kan your response, because for numbers of students only, how long the class has session been through last week or last 2 weeks? The sessions online class, how long it took? Is it around 1 hour and a half or 1 hour or less than 1 hour?
Maximum 2 hours lah, maximum.
Oh serious lah, sembang apa tu namanya?
Saya kena berlaku jujur doktor. Saya mewakili kawan-kawan saya sebab subjek ni diakui memang sangat sukar. Jadi saya harap doktor kena bantu kami lah. Sangat sukar. Sebab kami berhadapan dengan orang kata situasi sebenar. Bila kembali kepada teori ni, esok jam lah.
Okay lah, tak ada masalah. Kita bantu each other lah. As I said lah, this class kita tak boleh terlalu rigid macam kita treat undergraduate. You all dah matches, right? Kalau you rasa teori itu kurang ke, abang mai lah. Kita boleh bincang, right? Lagipun mungkin lah macam apa yang teori tu, selalunya kita ada teori terkini, kita ada teori yang lama. Most of the times teori from the textbook tu yang outdated punya teori kan, terzagi. That are common theories. And then Meyerhoff is talking about the bearing capacity, because today is on bearing capacity failure kan. So I just said that kalau you nak tahu all theory, all are in books. Tapi kalau you cerita pasal new theory for bearing capacity failure, and then what are the latest apa kata development theory itself, semua tu journal. So bila cerita pasal journal artikel, tak semua kita akan pegang benda tu tau, sebab dia very fast, dia punya changes tu berlaku cepat sangat. Kadang kita tak catch up. So what I am trying to suggest to every one of you, just know what's the basic theory. Macam contohnya old dated theory, tersagi, Mayhoff, the six. And then kalau kata teori-teori lama tu, you kena tahu application dia dekat mana. Deep foundation ke, shallow foundation ke, whatsoever lah. Okay. Without further delay or ado, let me start my class session today. So this will be on the topic, okay. I think that every one of you can see my slide. So saya mungkin akan campur-campur sikit lah sedikit BM ke BI. So cerita pasal subjek ni dia lebih kepada kita ambil case study, kemudian kita analyse the case study by having some sort of theoretical background, and then kita ada analysis, kemudian apa yang kita boleh ambil pengajaran daripada failure ni ataupun the case study. For example here, the foundation's failure mechanism. So talking about the failure mechanism, any one of you understand what are the failure mechanisms are about? Ataupun foundation tu, apa sebenarnya foundation? I think that kalau saya dengar balik from the background, all of my students just now, yang berkaitan betul-betul infrastructure, the only one saya rasa Afif lah, yang Encik Aiza, Encik Tamizi, Puan Siti, dua tu jalan kan. So kalau kita cerita jalan, foundation jalan tu apa dia? Encik Tamizi. Apa foundation jalan?
Subbase lah.
Ya, betul. So, hari ni kita punya foundation berkaitan dengan struktur bangunan. But the case selected is on problem yang mana kita panggil dia sebagai case on the Transcona Grain Elevator. Saya rasa saya dah share dalam WhatsApp group tadi satu video berkaitan dengan the history of the Transcona Grain Elevator. How was the problem started, and then apa masalah-masalah dia sehingga berlakunya problem tu, dan apa cara dia orang mitigate to the problem. So the theoretical behind of this one, since Encik Tamizi asking about the theoretical, let me share. Actually saya tak nak share sangat lah sebab yang ni dia lebih kepada topik undergraduate tau. Since I want to just every one of you back, orang kata ingat baliklah semua benda yang berkaitan dengan teori. So saya just go through sedikit sahajalah, slowly ke apa kan. Okay, tadi saya tanya Cik Tamizi, kalau untuk highway, kita punya foundation is a subgrade ataupun subbase. For structure, our foundations we call it as a footing. Footing ni dia ada dua, ada yang deep foundations, ada yang shallow foundations. Dia bergantung kepada applications dan our punya design load lah. For example here, dia punya conditions for shallow foundations, dia punya syarat less than 3 meter depth. So itu shallow foundation. Kalau you ada problem, you have a weak soil, yang mana the soil is not homogeneous, kemudian the strength is not uniform, strength is not too high. So yang tu kita pergi kepada deep foundation. So kalau condition tanah kita kuat dan kita punya application less than 3 meter, so kita boleh pakai shallow foundation. So this is quite opposite to the deep foundation. Wait a second, sir.
Doktor ada kat situ. Kawan-kawan dengar suara saya?
Dengar Batam, doktor kata wait a second.
Oh, wait a second. Tiba-tiba. Okay. Mute. Afi dah buka puasa.
Esok baru nak start puasa 6.
Allahu Akbar.
Sebab
Okey lah
hari
tu.
fikir-fikir hari ni tajuk berat, kita tak jadi dah puasa.
Apa dah jumpa bilik minggu depan?
Tu kena tanya
Okey.
pasal tajuk.
Okey doktor.
Okey, boleh saya mencelah?
Okey.
Okay,
Boleh.
sorry lah kan. Itulah situasi di rumah bila kelas malam. Saya harap benda tu every one of you get used lah, sementara kelas face to face ke, ataupun kalau face to face kelas sekali tu je, then back to online, you have to hear on the voices. I'm sorry again. Okay, ini lebih kepada konsep dia lah. Kemudian bila kita pergi to the next one yang mana we want to understand the concept on it yang ni saya hanya fokus kepada shallow foundation because our next case study related to shallow foundations only. So when you want to design the shallow foundations, there are 3 conditions or the guidelines that we have to fulfill. For the first one is the adequate depth. Adequate depth ni is again we have to look at the depth must be sufficient to prevent any adverse effects such as temperature changes, climate changes, and also any additional loadings. The next one is a limiting settlement. So if I'm not mistaken, kelas pertama topik ni saya rasa Dr. Ng Kok Shin pun dah share berkaitan dengan settlement, bearing capacity, the most common words related in geotechnical failures lah. So limiting settlement ni dia berbeza untuk different soil. Ada clay lain value dia, sand pun lain value untuk settlement because different soil will have different characteristic and also the properties. And the limiting settlement also depending on the functional performance lah. It's again kalau you design for shallow foundation, kita nak tahu foundation tu application dia dekat mana. Kita nak pakai mat foundation ke, kita nak pakai shallow or pad ke ataupun straight foundations. So the next one is the FOS against shear failure. So FOS against shear failures ni dia ada banyak jenis. Contohnya ini contohnya limiting settlement kalau sand, clay, berapa nilai-nilai yang dicadangkan. Okay, these are the modes of shear failure, general shear failure, local shear failure, punching shear failure. Failure ni lah yang merujuk kepada bearing capacity failure mechanism. So dia bergantung kepada the soil properties. Again, kalau tanah tu associated with the dense sand or over consolidated soils of low compressibility, mostly kita assume general shear failure saja. Tapi kalau you encounter problems on loose cautionless soil, so this one we call it as a local shear failure. So the conditions for each failure dia different. Ada failure dia akan create bulging tilting, ada failure dia tak ada bulging tilting, terus dia ada drag down. So that is the worst scenario of the shear failure yang mana kita panggil dia sebagai punching shear failure. So when you want to design, we have to check the FOS number. FOS number depending on the structural capacity lah. You nak design untuk apa, railway ke, untuk highway ke, ataupun office loading. So let me check apa. Oh, dia ada ikon-ikon ni lah. Never mind lah. Okay. Then apa yang penting bila you design shallow foundations, there are some assumptions that we have to fulfill. For the first one, assuming that the dense soil fill along well-defined slip plains resulting in general shear failure. And then the loose soil do not fail suddenly and the slip plains are not well defined, so resulting in local shear failure. And very loose soil can fail by punching shear failure. So again, these are the problems of failure mechanism if you have a shallow foundations. So yang ni saya ni fokus kepada shallow foundations. So bila kita nak relate dengan settlement the next one we have to understand on the definitions. Apa dia bearing capacity, what is the factor of safety, contact pressure to apa, kemudian what is the allowable bearing capacity. So these are the things that we have to focus on. For example, kalau you design ataupun you calculate the Q allowable, we have to check the Q allowable kita tu is on the shear strength ataupun we calculate the Q allowable for settlement value. So if you have a settlement value, you want to check the Q allowable, so these are the formula given. So again, most of the time formula ni dia akan jadi confused bila terlalu banyak formula. Contohnya author ni, researcher ni bagi formula macam ni, researcher A, B different formula. So yang tu yang menjadikan benda tu lagi susah lah. But once again, selalunya kita akan pakai conventional formula unless stated. So you have to fulfill this formula by terzaki, for example, atau you have to fulfill the formula according to Meyerhof, or some problem may not stated what formulas or ataupun what theory need to fulfill or need to follow, but you have to look at the conditions. Kalau loading to incline loads, so the terzaki formula is not suitable, so kita kena pakai Meyerhof ataupun Versight. So conventionally, most of the time bila kita design for shallow foundation, these are the assumptions made by terzaki. Because terzaki assume that the soil is homogeneous. In real condition, our soil is not homogeneous. We're going to face different properties of soil at different depth. Itu yang selalunya berlaku. How do we know that? Bila kita buat ground exploration, kita buat site investigation, kita ada bolok data, so baru kita tahu that actually soil is not homogeneous from 1.5 meter depth to the maximum depth, ataupun once you meet the hard layer ataupun hard strata of the soil. So kat situ baru you nampak, oh soil kita ni bukan uniform. Oh, ada clay, ada sand, ada city clay. So yang ni cara kita nak overcome dia, apa design yang sesuai. Contohnya hari ni kita cerita pasal design kan, lepas ni kita nak tengok bearing capacity failure berlaku disebabkan apa, adakah design error ataupun post construction error ataupun pre construction error. So these are the theory ataupun assumptions made by terzaki yang macam Cik Tamizi mention lah. Mungkin some of you might afraid of having these kinds of formulas, concept and theory. But again, once you read the textbook, you understand it on it, is okay. I think that maybe it's good kalau kita ada time untuk kita read, or just attending the online lecture, I share what I have known, ataupun you can try dengan apa yang you have learned or read from your own experience, for example, so we can blend it together, so we can get the right idea what we are facing on about. Okay, just now on the assumptions, theoretical, on the bearing capacity. So the next one, how does it relates to the settlement? Of course, when you imagine, kalau kata apa-apa lah kan, kita letaklah loading, any kinds of load, for example, structure ke, ataupun machinery on highway, of course kita akan ada settlement, right? The settlement is a total vertical displacement downward. Itu kita panggil dia settlement. Dalam settlement ni pula, dia ada pelbagai jenis. Kita panggil immediate settlement, dia ada consolidation settlement, dia ada secondary settlement. All these settlements will give you different value because of it is depending to the compressibility of the soil. Kalau settlement on sand, berbeza. Macam tadi kan saya bagi limiting settlement untuk sand, lain nilai dia. And then limiting settlement for clay, of course different, because the clay and the sand itself, dia totally different karakteristik dia. Kalau you just imagine, clay dia punya particles very fine, right? Okay, kita break sekejap azan. Okay, azan. Saya Okay. Hello. Okay, boleh
Ya,
start
dapat.
lah?
Boleh.
Okay. So just now I stop here. So settlement ni saya rasa kalau bahasa Melayu orang panggil mendapan. Kalau kita panggil dalam details definitions, dia adalah pergerakan ke bawah yang mana awak akan nampak perbezaan dari segi soil volume lah, perubahan di segi padu tanah sebelum kita letak beban dengan selepas kita letak beban. That's the simple thing. Kalau simple things pun kalau kata kita jalan lah atas tanah kan, tanah basah lepas hujan kan. So kita nampak dah actually bila kita pijak on the ground surface tu dia dah berlaku settlement kan. Tapi settlement biasanya yang kita pijak tu taklah teruk sangat berbanding settlement yang berlaku di bawah foundations. So the foundation is a structure that transmit loading from the top to the underlying soil. So kalau kata tanah kita tak kuat, of course whatever superstructure yang you construct atas tanah pun akan collapse. Itu dia punya ideology dia. So the thing is that the soil must be strong enough to cater the loads from the superstructure. And then total settlement, so bila orang kata total settlement, is a total submission between immediate settlement, primary consolidation settlement dan juga secondary settlement. So what are the causes? The causes of the settlement is the reductions of volume air void ratio in the soil. So settlement ni dia can be resulted from the expulsions of the water ataupun reductions in the air void. So dia bergantung kepada proses lah. Kalau expulsions of the water, proses yang terlibat adalah consolidation. Tapi kalau kata dia melibatkan expulsions of the air voids, itu kita panggil compactions lah. Okay, yang ni pun saya tak explain lebih sebab dia lebih kepada recap balik. Sebab saya tahu kan kebanyakan bila kita bekerja ni, kita nampak real life, kita pun lupalah sikit. Tapi sebenarnya real life you all tu sebenarnya dah bagus dah. Indirectly dia dah bagi pada awak theoretical, konsep, cuma kita tak gabung ataupun kita tak recap ataupun kita tak recall kan, because kita dah tinggal lama lah. For example kan, if you ask me pun, because saya working in this academic education, so that is keep in mind. So benda tu ada lah, so dia tak hilang. But I think that benda ni pun tak hilang sebenarnya daripada tuan-puan, ada. Cuma kita kena recap dan recall always lah. So antara punca ataupun jenis-jenis settlement kalau kita ada uniform settlement, you can see that left and right sides building tu dia akan mengalami settlement in the same amount. Tapi bila you adanya tilting of the ground surface and then you can see that the building left at one side only, yang tu kita panggil tipping settlement. Somehow yang lagi teruk ni kita panggil differential settlement bila you can see that the difference on the left and right sides of the column having a cracked surface, that is a resulted from the differential settlement. So ada pelbagai jenis, ada pelbagai punca. So ini antara causes of the settlement. Okay, yang ni pun without details explanation, just to give you selalunya immediate settlement ni kalau kita ada sand layer. Primary settlement ni selalunya kalau kita ada tanah jenis soft clay. Secondary settlement is the time when consolidation reach 100%, but then after 10 years, 20 years of the construction end, settlement masih lagi berlaku. That's how you akan nampak kadang-kadang bangunan kita yang kita duduk tu pun akan ada rekahan, ada crack. Itu adalah terkesan daripada pergerakan tanah yang berlaku lah. So we can't say that once the building is stand on the ground surface, our building is safe. No. Selagi mana adanya climate changes, ada environmental effect, dia akan resulted to the settlement or ground movement. Okay, the next is on the, okay, ni antara contoh-contoh lah. Kalau you nak calculate settlement based on theory, macam mana? Kalau kata kita nak dapatkan settlement from the field testing, so these are the kind of testing that you can collect the settlement value. So, saya rasa Puan Siti pun quite aware kan, contoh-contoh field testing measurement for settlement calculations. Ada yang pakai MLT, ada yang pakai PDA, so it's up to everyone or the client budget lah untuk kita conduct the settlement on site lah. Okay, because the plate bearing testing is one of the important subtopic after this. I just show to you apa dia plate bearing testing and what's our result that we can have from the plate bearing testing. Again, it is the method on site to measure the settlement predictions. So what we're going to have after the plate bearing test is load settlement curve. It's very expensive and time consuming and very useful in coarse granular soil where undisturbed sample cannot or very difficult to be taken back to the lab. So this is the very good about plate bearing test. However, plate bearing test ni supposedly need to be verified lah dengan conventional ataupun theoretical concept of the settlement itself, because kita nak buat whatever we have from the site need to be verified from the theoretical calculations ataupun from the experimental results. So what we can see on the right side here, bila kita buat plate bearing test, plate bearing test dia adalah replicate ataupun dia try to predict settlement that we're going to have after we construct a loadings, after we construct a structure. But the constraint about the plate bearing test is the limited width. Dia ada terhad dari segi lebar. Sebab kalau ikutkan beban yang kita letak atas plate bearing test ni, dia bukanlah maximized size that we're going to apply on the grounds from our structure, right? So dia akan bagi on this the amount that it can gather from the machine itself. Tapi in reality, bila kita nak construct a structure, kita ada kan dimension kita, footing kita size berapa, and then loading yang kita apply tu berapa. So you akan nampak at the bottom here, it shows that the contact pressure, the bearing or the influence zone will be different accordingly to the load applied on the footing itself. So kalau you ada footing yang small size, contohnya plate bearing. Kalau plate bearing kita kecil, so ini je lah bulk pressure yang kita akan dapat. So the bulk pressure shows to you that the increase of the loads that will be given to you, the increase of the bulk pressure. So ini kalau kata kita punya footing lebar kecil. And then kalau kata kita ada footing lebar di besar, this is what we're going to have. How about kita ada rough footing, yang mana footing kita tu packed ataupun located close together. So dia akan ada berlakunya overlapping influence zone of the bulk pressure. So the effect of the bulk pressure, if you are not taking details site exploration, ground investigation, that will bring to you wrong justifications or wrong decisions on what's the footing size that you should carry out or what you should design. So it's very important lah, the plate bearing test, kemudian site exploration, in situ testing, mana-mana yang boleh membantu bagi data pada awak berkaitan dengan tanah, you can proceed. Tanah dia tak macam structure yang made of concrete, because the concrete itself can be predicted. Am I right? Betul tak? Sebab concrete ni dia macam, contohnya kan, bagi saya lah, concrete dia bukan live. Dia tak hidup. Live kat sini dia tak hidup. Macam tanah, dia hidup. Cuaca kering, so dia akan behave, orang kata apa, baiklah kan. Sebab dia tak ada additional loads. Dia tak ada air masuk dalam tanah. So, in order to prevent any failure, during that dry season, it's okay. You nak buat construction masa dry season pun okay. But somehow in Malaysia, kita boleh nampak lah kan, half year, okay, dry monsoon. Nanti separuh lagi berbaki tahun kita tu adalah wet monsoon. So bila you nak buat construction, kita akan avoid kan wet season, right? Because masa tu lah groundwater table increase, akan ada berlakunya high intensity of the water lah, rainfall tinggi semua. So that's why I said tanah ni dia tak macam concrete, dia hidup. Dia akan behave differently. So concrete you can predict dia punya behavior, but the clay ataupun the soil itself very difficult to predict. The behavior itself is difficult to predict. So it's like the human lah kan. Hari ni you jumpa dia baik, esok-esok you datang jumpa dia lain macam pula dia ni kan. Contoh hari ni you jumpa saya macam okey je kan, nampak dalam online senyum-senyum. Nanti minggu depan jumpa kenapa macam garam pula kan, lain pula kan. So I'm not saying that yelah, what I can say that daripada apa yang saya tengok, soil macam tu lah, geotechnical is something that you have to really spend on money, spend on time untuk faham characteristic of the soil. Different soil, different characteristic. And then kalau kata soil dalam keadaan kering berbeza, soil dalam keadaan basah berbeza. Ini belum lagi a new concept or new theory, we call it as a unsaturated. Unsaturated concept is very killer concept that somehow we try to make it a simple assumption yang mana tanah kita is saturated ataupun dry condition. But somehow bila you study on unsaturated kan, dia akan ada zone saturated, dia akan ada zone dry, dia akan ada zone yang mana dia di tengah-tengah. Kat situ kita panggil unsaturated. And then when you calculate the shear strength kan, dia tak straightforward macam kita guna teori more column. More column tu that simple assumption. Tapi bila you relate dengan unsaturated, kita nak kena tengok shear strength, the pore water pressure, the pore air pressure. So semua tu berbeza lah. So itulah saya kata tanah ni dia not easy to predict lah. So bila you ada project, you ada duit lebih ke, atau you can say that oh this soil is very difficult to estimate. So why not we invest in this kind of testing? Kita buat plate bearing testing ke, kita buat standard penetration test ke, kemudian you buat undisturbed testing, you buat disturbed testing, and then you carry out pula dengan lab testing. So bila kita ada complete set of the data, saya tak katalah benda tu kita akan ensure our project is safe. No, because some project can be failed due to many reasons. For example, human error, design error, post-construction error, so benda-benda tu. Tapi kita boleh kata a set of empirical and data will give you a good assumptions on design or any kind of the decision making lah. Itu antara saya punya pendapat, my personal pendapat lah. Mungkin encik tuan punya yang lebih berpengalaman mungkin ada pendapat masing-masing kan. So ini contoh lah, bila kita dah ada result daripada plate bearing test tu, and then we want to estimate or we want to predict settlement, so we can use this calculation. So again, because of our plate is that dia punya size of very limited, so now we need to do the corrections lah. You can see that how it is taken the QU footing from the plate, and then kita multiply pula dengan footing size over dengan footing plate, over dengan plate size, so kita akan dapat the ultimate bearing capacity of the footing. Okay, from the plate bearing test juga kita boleh calculate for sand. Just now for clay for example, sand pun this kind of the formula. Okay, ini pun I'm not showing in details lah because kita nak pergi sebenarnya lebih kepada case history. So the next one is on our topic yang mana bearing capacity failure on Transcona Grain Elevator. So I think that the previous ataupun video yang saya share dalam group WhatsApp tu very informative. Take your time sebelum tidur ke apa, lepas habis kelas ni, dalam 10 minit saja duration dia untuk you understand what is the Transcona Grain Elevator. Kenapa dia become a historic case failure? Sebab dia adalah case failure recorded by many researchers yang mana dia pun orang buat macam-macam kajian nak cari punca. Kenapa kan? Okay, antara yang you may expect from this class atau from this end session to discuss the bearing capacity of foundation and the relation with settlement limit, evaluate the failure cases using relevant theory, propose mitigation measures related to foundation failures. So yang nombor 2, 3 ni saya akan proceed next week lah. So yang untuk hari ni lebih kepada case description. Before we go further to Transcona Grain Elevator, so this is what is bearing capacity failure definition. So I just tell you ultimate bearing capacity, allowable bearing capacity, all those things related to bearing capacity of the soil. So a bearing capacity failure is defined as a foundation failure that occurs when the shear stresses in the soil exceed the shear strength of the soil. Ini yang complete definition. Yang mana tanah tu dah tak boleh carry lagi loads from the structure. So dia akan fail. Dia nak fail dalam failure mechanism apa? It can be general shear failure, it can be local shear failure, it can be punching shear failure. Bergantung kepada foundation you overlay atas tanah jenis apa? Sand ke, clay ke apa benda kan? Kemudian bila kita pergi in details, Transcona Grain Elevator ni, bila kita buka balik dia punya penceritaan, it was constructed ataupun begin in 1930. Tujuan asal dia untuk menyimpan bijirin, and then this is the area in Canada. So the purpose of the elevator was to provide relief for wind impact yachts during the months of the peak grain shipments. So it's like a transit area process lah, daripada process center sebelum dia deliver ke kawasan berdekatan in Canada. Kemudian Transcona Grain Elevator is a reinforced concrete structure. Dekat sini pun dia dah bagi tahu struktur dia apa benda. So that is the key related to the foundation type. From here, you can have some ideas, some other foundation to rough foundation ke strip foundation ke ataupun pad foundation. Logically, kalau kata this kind of the grain grain store grain, dia tak akan pakai single pad footing lah, dia akan pakai large footing size. So the consisting of an engine room and grain storage area. So the structure having some blocks such as engine room, storage area, kemudian having rows of 13 containers with a total volume of 36,000 meter cube. So it's very huge volume area untuk cater row 13 containers. Kalau you tengok dia punya video tadi yang saya share, containers from the top view is around ada 13 cube part lah kalau kita tengok from the top view. Sebenarnya dia adalah containers untuk menyimpan grain tersebut. So the construction is based on reinforced concrete slab measuring by this size with an upper and lower reinforced concrete slab 60 cm thick between which there is a space for emptying such as foundation structure with two slab and transverse and longitudinal stiffness is very rigid foundation structure. So it is stated that here it is very rigid foundation structure. So apa yang pentingnya information ni? Bila dia berkaitan dengan settlement. So you nak estimate settlement, kita nak tahu kan footing kita ni rigid ke, flexible ke, kemudian foundation kita ni is located at the center or it's located at the corner ataupun is located at the edge. So all this location it reflect to the assumptions bila kita nak calculate ultimate bearing capacity ataupun you want to estimate the settlement. So bila you have time to refresh balik on this topic bearing capacity, they can give to you the influence factor Q untuk dapatkan overburden pressure ataupun increment in vertical stress. So yang tu dia punya significant of this one rigid foundation structure semua benda. Okay, this is the idea of the building itself, yang mana dia ada workhouse, kemudian dia ada bin house. So the size is very very important to tell you what is the best footing to cater this kind of the structure, because structure ni bukan small tau, dia besar. So dekat section figure A ni dah shown to you foundation plan, kemudian B is completed before the collapse. At the first one, bila kita tengok dia for big large construction ni ataupun structure ni, it's not easy what we call it, dia bila dia dah besar, maknanya loading dia tu pun akan besar lah. The structure itself pun dah besar, tambah dia ada additional loads from the grain. So bila dia design dia tak design for the structure itself, dia kena design for additional loads inside the building. So apa yang berlaku? Foundation ni started construction excavation in 1911. Kemudian the first 1.5 meter of the ground were rather soft, but then the excavation penetrate into relatively stiff blue clay. Ini yang tiba-tiba unexpected. As I said, the soil is not homogeneous, it is heterogeneous. Unlucky for this construction, they not provide any site exploration. Dia tak buat apa-apa pun standard penetration test ke apa benda tak. Tetapi pada kedalaman design of 3.7 meter, dia the workers ataupun the site workers decided to do a loading plate test. So pada kedalaman 3.7 meter. Kat sini kita dah nampak lah sebenarnya when you want to start construction is supposedly started dengan ada site exploration, or you can have the standard penetration test, kemudian you can do a plate bearing test. And bila dia encounter different soil type, baru dia decide nak buat plate loading test. And then the test loading was applied using constructed wooden framework. So you just see that wooden framework density dia tak seberat density concrete. Itu yang kita kena faham sebab the structure itself has mentioned that it is a reinforced concrete structure. Kemudian plate bearing just use wooden. So kayu kan. So benda ni tak samalah untuk kita represent real loading yang akan ditanggung oleh tanah daripada struktur tersebut. So apa yang berlaku bila dia buat plate loading test and then do some calculations, so the capable of bearing a uniformly distributed load of at least 400 kPa. So, the maximum foundation pressure was not supposed to exceed 300 kPa. So kat sini pun dia dah ada contra info, and then they assume that the blue gumbo at the site had similar characteristic and adapt to that on which similar rough foundations of many heavy structures had been founded in the vicinity of an impact. What we can highlight here is that the simple assumption to construct this area Transcona Grain Elevator ni, dia hanya andaikan kita assume untuk site Transcona Grain Elevator ni tanah dia lebih kurang sama dengan construction yang dah siap bina berdekatan dengan kawasan kat situ. Sebenarnya dia salah. So dia tak boleh buat simple assumption untuk Transcona Grain Elevator tanah dia sama dengan tanah sekitar dekat kawasan-kawasan lain. Because kalau kita kena terrain ataupun kawasan tanah yang rata, okey, tapi kita tak tahu kan what's the overburden pressure yang berlaku dekat site area for example lah kan. So the best thing is that we need to do site testing jugalah kan. Bila kita assume macam ni, okey lah, contohnya saya nak buat projek dekat Penang. Saya tak nak buat site exploration because I have limited budget. So saya ambil je lah SI report yang lama-lama kan. Kemudian saya buat construction. I might failure in future because sekarang punya history tanah tak mungkin sama dengan 10 tahun history tanah, betul tak? Because last 10 years mungkin dia tak ada weather process yang massive macam kita ada sekarang dengan climate changes ni, environmental condition berbeza. So that's the thing that bila you nak design, we cannot simply taken the assumption from the previous site report or simple assumption tanah dia sama je sebab tengok bangunan dekat kawasan kita ni tak runtuh-runtuh pun, so kita boleh assume tanah ni sama. So that is not good lah bila you nak buat engineering practice lah. Okay, it was assumed that the steep blue gumbo clay at the site had similar characteristic and depth at the site of other complex. This is what I said. So apa yang berlaku? The settlement started bila dia pun try penuhkan Vigilin tu sehingga 87.5%. It's not fully occupied lagi dengan grains, tapi dia dah start settlement. Slowly you can see that the building tilt in the few angles. And then within an hour, the settlement increased to 300 millimeter, which is sloped to the west. And within 24 hours, the foundation soil collapsed and the structure tilt about 27 degrees. So this is the resulted from the actions of filling the grains itself. So just within 24 hours, you can see that the building totally collapsed. After this, barulah they started to have detailed investigation, they buat explorations, and then some limitation juga, they just use the optical observation to classify the soil itself. So they assume that the soil was uniform layer of clay, and then the geological structure of the site quite similar with the previous site project. And later on in 1951, these two researchers tried to found out what were reasons the structure failed. Until then, they found out that this is the soil profile. When you look at to this figure, from the soil profile through the bore log, you can see that the soil is inhomogeneous. Through the reading itself, using the unconfined compressive strength, you akan nampak kan the layer is changes. At the beginning, the strength is high, 108 kPa. And then bila dia go deeper, suddenly the compressive strength decrease. It's not supposedly happen. Kenapa dia punya unconfined compressive strength decrease? Because it has different clay ataupun different soil type here. So dekat bahagian atas ni kita akan nampak apa? Grey clay, and then here with some kinds of the silty gravel. But the QU ataupun unconfined compressive strength give to the reasons why the soil collapse or the foundations of the Transcona Grain Elevator collapse. So these are the reasons why it happened due to the soil strength itself. Kemudian the soil profile not similar, and then the geological features of the structure may not similar to the site area at the previous applications. So just to show you here how it is tell and explain the contact pressure below the footing, the underlying soil. So once you apply the footing on the ground surface, the contact pressure increase by depth. So bila you letak loading kecil, so the contact pressure smaller lah. Tapi bila you increase the loads, you can see that the contact pressure also increase. Just now from the borehole, it is show that the first upper layer of the clay soil having this high strength QU. However, below ataupun bottom of the clay layer here indicate the lower strength. So dekat situ, it's not supposedly happen. What we understand in concept, theoretically, once you go deeper, the strength of the soil increase. Tetapi untuk Transcona Grain Elevator failure ni, dia terbalik. Yang mana pada bottom layer ni, nilai strength dia rendah. Sepatutnya nilai strength dia tinggi. Dan bila dia buat contact pressure estimation, this is supposedly happen. So bila you increase B, you akan, if you started B dengan small size, this is the contact pressure that you may have. And then you increase the contact pressure of the size B, that will give to you bigger influence zones. So somehow, bila you letak plate load yang small size of the B tu dengan actual footing size, of course they will be different, right? Because plate load contohnya size dia dalam 2 meter. Kemudian real footing around 20 meter. You akan ada the condition where the plate load not give the real conditions of the soil itself because the limited size of the plate load. Tetapi kalau you letak real conditions, kalau kata plate load kita ni ada size yang lebih kurang sama size yang footing kita nak kenakan tu, they can give you the real conditions of the soil. So somehow in this problem, this is one of the reason kenapa footing tu berlaku is due to the size of the plate load chosen. And then the material itself. Okay, on top of this figure, it shows you how the slip plane started to occur. Maknanya it started at the edge of the footing, and then it is also depending on the angle of the soil. Kalau internal frictions angle kita besar, so dia punya frictions tu akan tinggi, so dia akan reduce the slip plane lah, the angle of the slip plane. Tapi kalau you ada footing on clay yang mana dia punya slip angle ataupun internal friction angle 0, so they can occur very huge slip plane below the footing. Okay, the failure mechanism. So this is supposedly relates, and excessive settlements take place due to consolidation and secondary compression and is caused by a decrease of the soil volume below the foundation. Therefore, it takes place rather slowly and the ground surface around the structure subsidized together with the foundation. So it is indicated by the figure 4.4a. And in terms of the bearing capacity failure, a failure mechanism is formed below the foundations and the settlement takes place much faster and without decrease of the soil volume. So therefore, the displaced soil has to find itself and exit, causing a ground heave in the vicinity of the structure. So this ground heave is a distinctive features of the failure of the Transcona Grain Elevator. So the failure mechanism is shows to you that how it is started to move and how it is created the bulging next to the footing edge. So you can see at the figure 4.4b, this is the bearing capacity failure mechanism for this footing of the Transcona Grain Elevator. Okay, heave ni selalunya berlaku untuk tanah jenis clay lah. Kalau sand, they can give you different failure mechanism lah. So the particular problem of the Transcona Grain Elevator was that the failure mechanism of the plate loading test were apparently confined to the upper stiffer clay layer due to the relatively small size of the plates. So the elevator foundations, however, developed a much deeper failure mechanism which entered the weaker clay layer significantly reduced the bearing capacity. This is how it says that kalau you can see how you can relate. Contohnya kalau ini adalah plate, so dia punya contact pressure dia kat sini. Just now I said kan daripada borehole tu kita ada upper layer, kita ada lower layer. So makna kata plate loading tu dia hanya predict settlement pada upper layer saja. Tetapi bila kita letak Transcona Grain Elevator Foundation yang size dia lagi besar daripada plate load test tu, So dia actually extend below the weaker layer. So kalau kita nampak kat sini sebenarnya dia dah masuk dekat bahagian lower layer. Lower layer ni lah kat sini dia adalah weak, yang mana plate load test tak expect ataupun tak predict dia punya settlement at this time. So that's end my presentation tonight. Any question? Any questions relevant to the case history? Case story? Case history boleh, case story boleh. Because dalam kursus ni, kita hanya ambil past case history saja untuk kita delivered, and then you need to relate how it is occurred, and then there are many cases. If you want to relate dengan real situations pun boleh, tak ada masalah. So the thing is that behind the lecture tonight, saya just nak cerita pasal bearing capacity, tapi lebih kepada failure cases. Failure case lah, kat sini saya hanya ambil satu case saja, Transcona Grain Elevator. Next week kita cover 2 cases, half from the Transcona Grain Elevator, the other half from new case. Okay, ada soalan tak? So saya tak adalah buat kelas sampai 2 jam tau. So saya minta maaf lah kalau kelas saya ni macam cepat sangat kan.
Saya ada soalan doktor, bukan soalan lah, nak tanya. Bukan soalan.
Kalau Pak Tam tanya ni saya kena buka buku.
Tak adalah. Kita orang kata
kita bincang lah, kita sembang.
Bincang.
Bincang lah dah.
Kadang-kadang macam kami saya dulu memang buat design lah, ya, design. Kita berhadapan dengan klien yang macam-macam. Klien ni dia constraint ni budget saja.
Betul.
Bila kita buat design sampai satu tahap, dia kata kena guna term allow for settlement. Maknanya kita membenarkan settlement itu berlaku, tapi masih kita kawal benda tu. Dia bukan fail, tapi kita kawal settlement tu. Jadi saya nak tanya doktor, apa pandangan akademik lah berkenaan dengan allow for settlement ni. Sebab bila kita design, kita tak boleh nak fulfill semua requirement dalam design, sebab kita kena tengok satu term lagi, budget. Budget tu sebab kita suka guna optimum design. Optimum design ni maksudnya kita design berdasarkan bajet klien kita. Kalau klien kita tak kisah budget, kita okey. Tapi klien ni pun faham lah kan, macam-macam rupa klien ni. Ada yang kata budget problem, tapi nak benda yang canggih-canggih lah. Jadi ada satu masa macam case settlement ni kita allow for settlement. Macam apa pendapat doktor? Dari segi orang akademik lah.
Okay, pendapat saya lah. Saya senang je saya buat analogi speed limit lah. Speed limit atas jalan raya. Betul tak? Speed limit bila kita design jalan raya pun kita ada curvature dia berapa. Itu kalau jalan raya yang jenis corner kan. Kalau straight road pun kita ada speed limit 80, 110. Actually bila kita design, sebenarnya kita design lebih pada tu kan. For the safety purpose, kita nak limitkan banyak tu. Sebenarnya kalau orang lebih daripada 110 pun masih lagi selamat. Betul tak? Cumanya to precaution dan tak nak lebih kepada worst case, so kita limitkan dia. Same goes to the foundation. So dia ada optimum design. That's why I said at the beginning my lecture tadi, saya bagi tahu ada 3 syarat bila kita nak design footing. Antaranya adequate depth, limiting settlement, kemudian factor safety. So bila you fulfill all these 3 things, there's supposedly no problems lah. Maknanya kalau klien you letak budget, okay saya ada duit banyak ni. So you have nak tak nak pun you kena minimizekan ataupun you go to the optimum design yang klien tu minta. As long as dia tak exceed our punya condition. Contohnya tadi limiting settlement. Kalau you nak design footing on sand, so yang limited berapa? 45mm. So buat je lah. Sebabnya kita boleh main kan masa design ni, kita boleh try and error. Size footing ni berapa dia punya settlement produce. But somehow bila post construction orang akan blame inilah design error lah apa benda. Orang tak kata budget constraint kan. Orang akan reflect balik pada itulah kan saya rasa as part of the engineer ataupun as part the consultant ke client, everyone ada dia punya limitations, and then my personal opinion, as long as you fulfill the 3 conditions in design for shallow foundations, and then you try to suit with the client punya demand, there should be no problems lah. Because this in Malaysia lah kan, dia tak buka jalan yang speed boleh pergi 200. Kalau kita tengok kat Singapura ke kat mana kan, ada satu jalan yang you boleh pergi berapa kan speed limit kan. Sebab Singapura dia very tight dengan dia punya rule. Dan kita tak katalah orang Malaysia tak ada disiplin, tapi kita tahu kan kontra dia macam mana. So in Malaysia kita kena pakai benda tu. Ini pendapat saya lah, Nah.
Betul.
Sebab Encik Tarmizi ask my opinion, as I said, saya akan pegang on part the design requirement. At the same time, saya try to fulfill apa klien punya demand dengan budget constraint. Kita tak boleh menang all conditions, Encik Tarmizi. Oh, kita
Betul.
nak ni macam ni. Jadi payah, betul tak?
Betul.
Yelah kan.
Betul.
Pendapat saya lah. Tapi kan balik kepada kita punya topik lah, macam saya cakap this course untuk FIE 705 dia akan main failure cases, most of the failure cases dia akan ambil overseas. Saya tak tahu lah kalau ada tiba-tiba dia nak ambil case study in Malaysia kan. Case study in Malaysia boleh lah, landslide in Malaysia very common in Malaysia, right? So kita boleh ambil one case study from Malaysia. Tapi from the course content, kebanyakan failure cases memang overseas yang dah lama-lama kan. As long as you understand how to relate kan, apa punca failure dia, teori sikit, analisis sikit, how it is mitigation works. And then talking about your assignment one, I think that kalau your concerns on the theory concept, just go to any kind of a textbook, you try to get the definition itself firstly, baru you start menjawab untuk design and analysis. Kalau you tak relate dia punya teori konsep you payah sikit nak buat dia punya design and analysis. And then mitigation and solutions, you can take up from any practices, experience ke mana-mana yang you rasa relevant. Because the assignment dia tak letak budget constraint tau. So you bagi je lah berapa kan analisis dia macam mana. Tapi dia kena ikut dia punya limitation design guideline. Macam tu je lah kan.
Macam kes Transcona punya isu ni. Kita study on satu research daripada orang-orang itu, ataupun ada ramai lagi yang buat study case study Transcona ni.
My opinion, if you search on Transcona Grain Elevator, there's a lot of researchers did on this topic. They gave a different point of view from different perspective how they analyze the problem itself. The topic is the Transcona Grain Elevator. However, the approach they understand and they come up with the latest solutions that will be different compared to what's presented or recorded in 1915, for example. Because in 1915, they only used conventional analysis. But now, talking about the latest, if you want to study on Transcona Grain Elevator, yes, it's okay. But you have to use the latest approach solution. For example, finding element method ke, you guna any kind of solution, software, boleh. Banyak je researchers kan, cuma dia punya different approach, angle, perspektif tu dia nak faham daripada cara berbeza lah kan. But the concept geomechanics failure masih lagi sama. Tu tak lari.
Okay dah.
Alright. Okay ke kelas sampai sini saja?
Okay
Doktor.
Yeah.
Saya nak tanya satu soalan.
Okay.
Kalau untuk Macintosh Pro punya testing, adakah apa orang kata reading untuk kalau kita nak dapatkan bearing capacity, adakah Macintosh Pro tu result dia tepat untuk dapatkan reading bagi bearing capacity, Doktor?
Tak cukup. Bearing JKR probe untuk certain application and simple application, contohnya you nak construct highway, okay. Tapi kalau you nak construct for large structure, foundation untuk big structure kan, building single story apa, JKR probe dia tak cukup. Because bearing capacity dia JKR probe hanya bagi bearing capacity, dia tak bagi soil strength. Kita nak tahu soil strength yang lebih pergi kepada 30 meter, sebab the limitation JKR probe ni dia tak boleh pergi lebih daripada berapa 12 meters sebab kalau boleh pun dia kena extend road kan. So the reliability data tu kurang lah berbanding you ada SPT test ke apa benda kan. Yang ni pun back to budget jugalah kan, betul tak Puan Siti?
Betul. Cuma
Hmm.
saya nak tanya pada pendapat doktor lah. Sekiranya kalau macam kita buat construction ataupun construct satu area tu hanya berdasarkan pada result Macintosh prop sahaja. Kemudian design tu based on pada satu testing tu sahaja, dan kebetulan masa buat construct tu air dia punya water table pada kawasan tu adalah terlampau tinggi dan tiada piling di situ, hanya ada pad footing sahajalah. Adakah akan berlaku pergerakan tanah nanti doktor kalau condition macam tu?
Kalau saya for sure akan ada, whatever it is dia akan ada. First because dia accounted groundwater level tu. Once you encounter groundwater table, you have to do details site explorations. Contohnya, you nak kena dapat data daripada piezometer, inclinometer, semua benda tu kan. So, JKR probe test, again, kalau kata for fast reading, yes. Tapi for long-term stability, you kena buat lain lagi testing. Tak cukup. Boleh Puan Siti?
Faham. Cuma sebab based on the actual situation, dia hanya site tu hanya buat satu testing sahaja. Jadi masa kerja-kerja korekan dijalankan, kita tak jangka sebab kawasan tu adalah kawasan tambak laut. Jadi bila terjadinya kes macam tu, bila korek saja dia punya keadaan tanah tu sangat loose lah. Jadi takut juga kalau ada apa orang kata settlement, takut juga sekiranya berlaku settlement dengan cepat dekat situ. Jadi itu yang nak tanya pendapat doktor. Kalau doktor kata dia punya bearing capacity kalau Macintosh prop tu tak mencukupi, mungkin ada solution lain ke doktor selain daripada testing tersebut?
Pendapat saya tak cukup, dan kalau boleh lah, kalau you ada the nearest past construction yang ada SI report, you cuba ambil site report diorang tu. At least dia boleh jadi kita punya secondary data, secondary info lah. Whatever it is, kita boleh support in our design, because satu JKR probe saja tak cukup. Lepas tu you dah jumpa high water level. Itu dia jadi macam incomplete lah bagi saya. Tak, JKR probe test kalau you nak buat untuk hard layer, simple testing, boleh lah. Simple testing untuk simple application kan. Kalau reclamation area, kawasan laut, semua tu, supposedly if you can conduct borehole test, standard penetration test, itu lebih patut dan padan lah. Kalau tak boleh, ambil SI report yang area situ yang pernah buat construction dan projek pun dah complete ambil site report, diorang tengok diorang punya report as kita punya backup lah kan, guideline, kita punya backup untuk kita design ke apa benda lah.
Okey, faham doktor. Terima kasih.
Okey, sama. Okey, Afif ada soalan? Cik Zamir?
Saya tak ada doktor.
Okey, kita jumpa minggu depan. Weekend hari Ahad. So far tentatifnya hari Ahad. Satu lagi, jangan lupa attendance you future.
Okey doktor.
Dr. Eng dia buat attendance macam mana? Ambil daripada sini ke? Microsoft Team direct ke?
Tak, you future. Sama je.
You future lah. Okey, sama Alright.
Okey.
Thank you. Selamat malam. Jumpa lagi.
Terima kasih, doktor.
Assalamualaikum.
Assalamualaikum. Terima kasih doktor.
Terima kasih.
Sama.